and I thank you all for giving this opportunity. It's okay. Let me start the session. Okay, can you give me the presenter access so that I can go ahead and sharing my tech? Yes, I have a tech to be presented.
Yes, sir. Sir, directly you can click your presenting, sir. Presenting screen.
Okay, I can.
Yes.
Okay. Okay. Please confirm whether you can see my tech. Can you see my deck? Can you confirm? Can somebody confirm? Hello?
Hello, sir.
Yeah, can you all see my deck?
So, presentation is not visible, sir.
Not visible? Okay. Okay. Is my screen visible now?
Yes, sir.
Okay.
Yes.
Okay, thank you all. So, okay, I'm starting with this. It is an architectural mindset. Okay, so I mean,
Sir, you can go for full screen, sir. It is not in full screen.
Okay, sure. Yeah. I request people who are not speaking to go on mute because I'm hearing a lot of background noise. Yeah. So a request so that, yeah. Okay, thanks everybody. So I would like to, thank you, sir. So I would like to begin with this slide where I'm asking the students not to follow somebody else's path. I mean, this is an IT or a computer science perspective, in an information technology perspective, where don't chase programming languages, products, which basically emerge from time to time. So try to create a path on your own. I mean, you will see the context basically in the coming slides. So I would like to begin basically with my own experience. Okay, even though I have put it as 2000 to 2020, my experience starts from 1995, where I was an electrical engineer for the initial 3 years. Then I wanted to shift to IT. So I did my master's in applied electronics, which was in VLSI design, and then changed over to my IT. Okay, so I'm going to pitch this deck basically in that context. So I'm not handling the engineering. I'm not going to handle the engineering experience. Okay, so when I came out of my college, it was year 2000. You all know there is a famous Y2K problem all over the world. I mean, every mainframe program, for want of saving the space, they would have coded all the dates with just year as 2 digits. So instead of coding the dates as for something like, for example, 12th July 2020, they would have just coded as 120720. So you won't be knowing whether it is 1920 or 2020. I mean, that's the Y2K problem, right? So it became a big bang buck generator basically for the software companies of converting these 2-digit dates to 4-digit dates. So those were the days when I came out of basically my ME, and the first sentence will tell about, I mean, the typical mindset of a outgoing college student. So we will come to know what is the emerging technology, which is basically talked in the town. Your seniors will be talking about it. There will be seminars being conducted in the colleges. I mean, you will basically see career options. So everything will point to a particular emerging technology at that point in time. So when I came out to the college, Java used to be the buzzword. Whatever you hear about, everything will be in terms of Java. Java, enterprise Java beans, Java servlets, Java applets, everything will be Java. So we had, I somehow want to get into a career with Java as the option. I mean, that was my mindset at that time. Okay, so I started getting aligned to the technology and prepare very seriously for anything with the word Java. So I used to prepare. I used to study and prepare extensively on that. Then get a software company. Being an ME graduate, I was placed in Tata Consultancy Services with lot of dreams. Basically, I entered into TCS. Okay, so I was assigned a project which was based on Visual Basic and DB2 mainframe as the background. Come on, I mean the balloon was basically pricked. The big balloon which I was having in my mind, the Java balloon, was pricked immediately on day one. So I was assigned basically a client-server technology with Visual Basic 5 as the front end and DB2 as the background. So I completely got dejected. Come on. So I have to somehow get into a Java project. Okay, but it was not so easy. Okay, so for a budding youngster who doesn't have experience, you cannot choose the projects. Okay, you have to work in the projects where you are. Okay, but you can parallelly keep experimenting and experiencing yourself in others, but you don't have too many options. So slowly I started gathering experience, basically whatever I worked. It was basically, it was AIG, an insurance company with this particular technology. So I slowly learned the nuts and bolts, basically, of how a software is architected. So what is a front end, what is a back end, what is a database, what is a middleware. So all those things basically we came to understand. But within my mind, the desire to get aligned to Java was always there. I mean, it was burning deep in my mind. And so I was still not out of touch with Java. I was trying to basically learn Java, try to get certified and all those things. Okay, but the fate basically has other ways. So since I have gained experience in particular field, the project managers basically in TCS, they don't want to leave me alone. So I mean, after gaining a couple of years of experience, Java was not the project managers just had Java as one of the parameters, okay, while choosing people for their projects. Okay, there is something else which was very important, basically the domain knowledge, so the application knowledge. So that is what they were looking for, and they valued basically my experience, what I was in. So they don't want to let me go basically to a new Java project. So then I moved on to multiple other projects. I also happened to work on Java, but it became one another technology where I worked in. Okay, so the desire slowly got quenched. Okay, so then a gyan, basically a bulb blew in my mind. Okay, so any technology, as the years progressed, I came to understand, okay, there are multiple technologies I worked. I worked on Java, I worked on Microsoft CRM, I worked on DB2, I worked on SQL Server, I worked on Visual Basic, okay, multiple technologies, multiple things, but the domain was same, insurance, for the initial 5-6 years, okay. So then I ultimately realized shelf life of technologies are very few years only, okay. They keep on changing, okay. When I came out of my present in 1995, Visual Basic, Power Builder, Oracle Developer 2000 used to be the buzzwords. There were companies centered around it, you know. For example, there was a company by name Vetri Software, which was focusing on Power Builder. There was a company by name SquareD, which was focusing on Visual Basic based software. There was a company by name Pentamedia, okay. So it used to be called Penta 4, okay. They were specializing on Oracle Developer 2000, but none of these companies exist today, okay. So same with the people. If you try to get aligned with a particular technology, you have to go to the bust, okay. You have, because things change. Shelf life of technologies are very few years, okay. All these companies have gone bust because they got attached basically to a particular product or technology. Okay, that is one realization. That was the first gyan which came to me. Okay, everything is okay? Is it clear? Whatever I'm speaking, is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay, thank you. Then there is second realization, second gyan which came to my mind. Okay, whatever project I work on, there is one thing which is not at all changing. Okay, that is nothing but the data. Okay, and data never changes, but the way in which the data is stored, what only that alone gets changed. Okay, so that is the second realization I got it. Okay, the second gyan. Then third gyan was on multiple fronts. Okay, so the positive attitude, communication skills, presentation skills, behavioral skills, negotiating skills, coping with corporate politics, ability to work smart instead of working hard. Don't burn midnight oils. Okay, you have to work smart. Domain knowledge, okay, and reuse instead of build from scratch. When you are given an assignment to do in any IT industry, the first thing you have to do is don't start working on day one. You have to basically search whether any work has been already done in that aspect. Are there any reusable components that are already available basically in that? So you have to, instead of building from scratch, you have to reuse, and you will be halfway through already in the solution. Okay, that is another thing which I learned. So technology, okay, became the last. Technology is also important. Being in an IT industry, technology is important, but there are much more things which are important. Okay, the fundamental which I found for everything is data. Okay, so with that I go to the next slide. Okay, now this is the slide which I prepared basically for the sake of outgoing college students. Okay, so when you come out of college, you will have all these options. Okay, which one to choose? Should I get specialized in Java? Should I specialize in Informatica, Microsoft? I mean, if you see here, there are programming languages, there are databases, there are scripting languages, there are artificial intelligence based AI languages like Python, R. There are products, customer CRM products. Then there is an ERP product, SAP product. Okay, there are multiple options that are available. Okay, so how do you choose a career option? Should you choose based on a particular software? No. I mean, what is common basically to all these things? I mean, that is what you have to slowly start exploring. Okay, I would also like to talk about the hype cycle. I mean, as I talked about the hype, whenever you come out of the college, I mean, Gartner basically has published something called as, he publishes a hype cycle on various technologies, on various topics. Okay, so this hype cycle is based on emerging technologies. So there are actually 5 phases. The innovation trigger, meaning where the hype slowly builds up. Okay, so this is the area. I mean, this is as per August 2019, where hype is building on all these aspects: quantum computing, 5G technology, 4D printing, blockchain. See, all these things, hype was building up. Okay, then industry slowly realizes, okay, even though there is a hype, there are, I mean, POCs basically started getting created. Okay, that is the peak of inflated expectations. Then after some time, you have to check on the adoption. The hype, there are multiple things on the hype cycle. Okay, right? But what is actually getting adopted by the industry? Okay, so that is where the trough of disillusionment starts in. Okay, so where people were hyping as if everything will get replaced, but nothing of that sort happens. Here and there are few adoptions. Here and there are few POCs. I mean, that is the cycle of basically your disillusionment. Okay, then slowly there is a slope of enlightenment. So the slowly steady states start coming in. Okay, then comes the plateau of productivity, where there will be an industry-wide adoption of a particular technology, basically for a particular cost. Okay. So this is the Gartner's hype cycle. I mean, it is published. I request all the students basically to go through. It is available on Google. In whichever area of interest, you can go and type Gartner hype cycle for artificial intelligence, Gartner hype cycle for emerging technologies. Like that, you can go and type and get this hype cycle and find out what is being hyped about, what is the reality. All those things are published here. Okay. Then I would like to now come into the a typical software architecture. Okay, so let's talk business today now. Okay, so the focus of my today's session. Okay, so there are multiple layers. I don't want to get into too extensive in this. Okay, so you have a presentation layer, you have a business layer, and I have a data layer. I already made my point through. Okay, there are multiple things which are changing, but what is not changing is basically the data. Okay, right? So I'm going to focus basically on this. Okay, now I said I made an important statement, right? Data hasn't changed, but the way in which data is stored, that is only changed, right? So that slide precisely talks about it, right? So in the 1970s, in fact, prior to 1970s, okay, we had only flat files and VSOM files, okay, hierarchical databases like IMS. IMS DB is an IBM product which works on hierarchical databases. Then we have VSOM-based flat files. This used to be the talk of the town in 1970s, where people will be writing COBOL programs, KICS programming for synthesizing all these things. So then came in the 1990s, slowly RDBMS came into picture. So Oracle, SQL Server, Power Builder, so all these things basically start coming about. So there were extensive research and there was extensive products that are coming in, and slowly the architecture was also changing. There are two parallel paths which I'm not showing here, right? So mainframe is to be the mainframe, and to an extent mid-range computers like AS400. Those used to be the only things prior in those initial days. So then slowly, where you have only dumb terminals, okay? Your KICS screen is not basically intelligent, okay? You had dumb terminals with entire computational power on the backend mainframes, okay? So that used to be the technology. So it is nothing but your centralized technology, right? So where the terminals are just dumb. No programming or no synthesizing part on the clients. Okay, then RDBMS introduced something called as a client server technology, where the computation was divided into two. Part of the computation was done in the client and part of the computation was done on the server. So at the birth of RDBMS, client server technologies also came into being. Then from 2000, again, RDBMS hasn't changed, but there was birth of web-based technologies. So client server saw the big boom of Visual Basic, Power Builder, Oracle Developer 2000 and all those things. Then year 2000, Big Bang started the Java buzzwords, okay, everywhere. And client server was slowly dying its death. So Visual Basic, Power Builder, Oracle was slowly dying its death, and slowly Java was coming into picture. And there is one another trend, one another thing which was started happening, okay? So previously, there is no separate data storage or synthesis for reporting purposes, okay? So everything used to happen only on the main database, main application, okay? So where there used to be overnight feeds basically for reporting purposes. They won't disturb the day, okay? When the businesses were happening, they will run overnight batches basically to produce reports, okay? Year 2000 saw a distinct mindset change where they split basically RDBMS into two. There used to be a main OLTP system, which is basically the heart of any business, okay? online transactional processing system, where your day-to-day online transaction, let it be online or offline, okay, all transactions basically are done in OLTP systems, and there is a separate set of systems which are called as OLAP systems, online analytical processing systems, where the birth of data warehouse. People like Bob Inman and Ralph Kimball were the pioneers basically in these technologies. They introduced, everything is nothing. There is one fundamental aspect is nothing but data is not changing. The way in which the data is modeled, the way in which data is stored, that is only changing. That is what you have to basically understand, right? So then after 2008, then came the big data world, okay? So you had RDBMS world, you had OLAP and data warehouses, and slowly 2008 saw the big data world, introduction of the big data. So you have document database, column stores, key value stores, then Hadoop, MapReduce processing, all these things started coming into picture, okay? So now we are in a phase where all these things coexist together. There will be certain applications which are running on RDBMS. There will be certain reporting applications which are running on data warehouses like Teradata, Oracle Hexadata, right? So all these things. Then there will be big data systems which will be running on Hadoop. Today it will be Spark and Scala, right? So, and there will also be databases, NoSQL databases, basically to store unstructured data, okay? So till 2008, we used to have only structured data sitting in a flat file or a table, right? But after 2008, world has slowly started adapting Facebook, Twitter, WhatsApp, social media, right? Everything. So you need to derive intelligence. You need to derive monetization, basically on all these aspects. So structured data just became unstructured data and semi-structured data. You are now today having XMLs, JSONs, everything, right? So you have to have a system where you need to synthesize structured data, unstructured data, and semi-structured data, okay? And you need to have a way of data design. The way in which the data has to be designed is called as polyglot persistence. Okay, I would like to give a small example, to drive my point, okay? I said data hasn't changed, only the way in which the data has, right? So I want to drive that point, okay? Okay, if you see here, so I have taken the same college example, okay? College, department, subject, lecturer, student, and class, okay? So I don't know why it's not working. Okay, so this is how it used to be stored in 1970s. So everything will be a file. So there will be a college file, department file, subject file, lecturer file, student file, and a class file. So then it became hierarchical data models. The same data, but with a set of relationships. So college has departments and infrastructures. Departments will have subjects, lecturers, and students, and subjects will have theory and lab, okay? So this becomes one hierarchical database, okay? There will be one another hierarchical set of tables where the subject, what are all the theory, subject will have theory and labs, right? So who is teaching that subject and who is the student? So we will have hierarchical stores, something like our folder structures today, right? So this came into picture. Then slowly people realized there needs to have many-to-many relationships. So, right? So for example, one lecturer can have one subject can be taken by multiple lecturers, and one lecturer can have handle multiple subjects. One subject will have many students, and same subject will have multiple subjects, basically taking the theory and labs. So this is basically called as a network data model, okay? So hierarchical, pure hierarchies don't work. It basically complicates the situation. So then came the same data. Okay, I haven't changed anything here. College, department, infrastructure, subject, lecturer, student, theory, lab hasn't changed. Okay, from flat file, how it progressed to hierarchy, how it progressed to network. Okay, then came the relational data model. How it is getting stored here. The same example, college, department, infrastructure. Okay, so this is how you will have the normalization, 12 chord rules, blah, blah, blah. I don't want to get into the details. I just want to give a hint of how, I want to drive my point, okay? Data hasn't changed. The way in which the data has been stored, only that has changed, okay? That is what I want to drive, okay? Then came the NoSQL data models, okay? So all these things basically can be stored in key value pairs, white column stores, documents for semi-structured data, and graph databases, again, basically for all these complex machine learning algorithms, okay? So this is how things are, okay? So back to the same slide, okay? I hope it basically people got the point. Okay, now on to the next slide. Okay, so I have talked about data, how data is stored. I mean, how we had the client server technologies, how we have the centralized technologies, web technologies, what is OLTP, OLAP. Okay, so all those things are same. Now coming back to the today's context. If I have, so we have got the point, right? Data is not changed. Only the way in which data has been stored. Basically, that is what is evolving and that is what is changing. Probably new types of data are getting adopted. So previously, we didn't have the possibility of computational power for synthesizing unstructured data. But today, we had the capability to synthesize even unstructured data. Okay, that is what is changing. But data is still data. Okay, so now how do we build a carrier? Basically for as a data guy. So now that we have got, data is never going to change. The format with which the data is going, that is what is going to change. How do I adopt a carrier with data? Okay, you can be safe. If you choose data as an option, you can be a very safe bet because you have to just track how the data gets computational, how it gets computed and how it is getting stored. Okay. So this is one of the possible carrier progression for a data guy. Okay, so I won't say this is complete. For example, there can be reporting guys, okay, like Tableau, Power BI. Okay, this also I am considered an ending data analyst. Okay, so in the modern data science world, we have data engineers. Okay, basically we will do the data synthesizing of the unstructured data. I am clubbing them with the ETL guys in the data warehousing world. Okay, so some form or the other, I can fit basically in one of these pockets. So data analysts. So how do I now slowly start thinking about data? Okay, how do I build a carrier about data? I mean, that is what I want to talk about with this slide. Okay, so all you require to begin with for data analysts will be SQL, simple ANSI SQL. Okay. Be very strong in ANSI SQL, but the way in which data has been organized, that should be very, very clear in your mind. Whether the database is hierarchical, whether the database is in flat files, so everything can be ported onto tables, okay? And then you can still use SQL to combine them and get a data set, okay? But the way in which the data has been stored, you have to be very clear on that, okay? So that is the first thing you have to then build your SQL skills. Okay, have the data modeling skills, how the flat files are organized, how the relational database modeling needs to be done, how the third normal form has to be done, how the denormalization has to be done, what are all the chord rules. So all those things you have to just follow. But there can be different technologies which come to your aid for data modeling. If you see, you will have a tool called Erwin. You will have a tool called Sybase Power Design. You will have something called as IBM InfoSphere Data Architect. All these things do the same. Here and there may be some additional features basically to work with data, but the underlying models don't change. Okay, so the data analyst, SQL will be your skills, okay, which you have to be very strong at. Then you slowly progress to as an ETL or a data engineer, where in the modern data science world, you have to think about Python, you have to think about Scala, Spark, R, multiple things. In the traditional data warehousing world, you have to talk about ab initio, you need to talk about Informatica, you need IBM's data set, okay? So all these things will come into picture here. You need to get, thing is extraction, transformation, and load, okay? This can be done by simple PL SQL programs also. So these are just case tools which are coming to your aid to lift and shift huge tons and tons of data, okay? That is what these ETL tools do, but they are nothing but SQLs. Okay, so you can slowly extend your SQL skills to adopt products which basically come to your aid. Okay, so that is the career progression as an ETL developer or a data engineer. Then you can progress basically to data modeling, where as you become senior, so modeling data, I mean, for a particular context is very, very important. So data modeling also follows a pattern where you need to develop a logical model, physical model. First is the conceptual model, obviously, which comes under the logical data modeling. I mean, the pattern will be the same. So you will create a conceptual model, then you create a logical model, then you create a physical model, and ultimately, which basically consumes data and store it ultimately in a database. Okay, so I don't want to get into details, okay, on any of this. I'm just giving you a hint how you can think about it. That's it. Nothing more than that. Okay. So data modeler is the way in which you just organize data. Okay, you build conceptual models based on a requirement, you extend them into logical models, then you physicalize them for a particular target technology. It can be Oracle, it can be SQL Server, it can be Sybase, okay? The physical will be as per the target technology, but conceptual and logical remains the same. Then comes the data architect. So you have to think beyond the modeling world, okay? So there are multiple other aspects of it. For example, data security, data entitlement, data quality, metadata management, data lineage. So there are multiple things that are coming into picture. So all those things you have to think about as a data architect. So then you progress basically to the data scientist. So I have tons and tons of data, structured data, unstructured data, blah, blah, blah. How do you monetize those? How do I derive value out of it? So how do I run machine learning algorithms on top of it? So for this, you need to have programming skills, you need to have statistical skills, you need to have a fundamental understanding of the data, how it is stored, whether it is in structured or unstructured or semi-structured. If it is structured, how the data is, whether it is in flat files or hierarchical files, or whether it is in relational. So all those knowledge, and last but not the least, the domain knowledge. So if you are working on a data science project in criminal justice system to aid basically the police department, you have to turn yourself into a criminal, at least into your mind. I mean, I'm hyping this. I mean, that's how a data scientist will think. Okay, you have to think like a criminal, basically to aid the police and derive, monetize data from the trail of data which a thief or basically antisocial element would have left. Okay, I mean, domain knowledge is very important. I mean, just that is what I'm trying to drive the point. If you're working for an insurance company, you have to think like an insurer. If you're working on a data science project for a banker, you have to banking, you have to think like a banker. So you have to turn into that role. So then that becomes your data scientist role. Then last but not the least, nowadays, see 15 years back, you will hear about only, you won't even hear the words, CEOs, CIOs and all these things. There used to be only called as managing directors, okay? So all those things are general managers, managing directors, basically in the manufacturing world. After the IT, you hear words, acronyms like CEOs, CDOs, CIOs. Off late, in the very recent past 5 years, there is a new role that has got created, which is nothing but the chief data officer. He has the same footing as that of a CEO. Okay. Previously, data used to be a liability for every company. They used to think about how do I store data? How do I archive data? What do I do with data? Okay. Because of audit requirements, I am supposed to store data. I don't know what to do with this. Okay. It used to be liabilities, but today data has become an asset. So you derive tons and tons. I mean, Google is a very good example, right? So I will give you a small example. You go to IRCTC and try to book a train ticket. Okay. You get a, but unfortunately the IRCTC, you know how it works, right? Within the 5 minutes, for example, you are booking a Tatkal ticket, okay? Within the 5 minutes, all the Tatkal tickets have run out of steam, okay? You got a waiting list. Now, you go and suddenly you get a pop, basically from your email, right? So you get an email from some source stating that from Redbus, okay? Is your ticket waitlisted? Why don't you try Redbus? So you will be wondering, how the heck Redbus knows that my ticket has been waitlisted in IRCTC, okay? That's how data science works, okay? That's a small example how the data science works, okay? In a company's data, I mean, which has become assets now, there is a post which is called as Chief Data Officer. So then, lastly, I would like to talk about ultimately how the data basically fits into the business, day-to-day life cycle of a business. Okay, any business, basically it consumes data as well as it generates data. Okay, all these data go and sit in data models, which are basically done by data guys, the data architects. Okay, then data along with metadata forms the information, meaningful information. Okay, data without metadata is nothing but raw data. Data with metadata will become an information. So information is consumed by software applications, and software applications are run by business processes, and ultimately the business processes what makes ultimately the businesses to flourish and run. So with this I stop. So I think I hope I have done justice. I think I've neared my time. So I'll stop. Any doubts? I am open to questions.
Thank you so much, sir. Dear participants, you can just post your queries in your chat box. Or you can unmute yourself, you can just raise your queries so that the speaker can answer you.
Okay. I hope the session was useful. Okay. So I have a question. How do I see the chat? I saw a pop-up, but okay, here it is. Okay. Okay, I have got a request basically to share this deck. Yeah, sure, I will do that. Magesh, sir, I request you to just collate the emails and then send it to my email, which will
Sure.
be. So you can send it to me this email ID. So I can send this deck to everybody.
Sure, sir. Sure. We'll send the email IDs.
Sure. I hope the session was useful. I mean, I hope it just trickled your thought process. See, I'm not giving a big gyan here. Okay, I know you guys will be very more in touch with the latest technologies. You will be knowing what exactly is the latest trending in the world. So I just trickled your thought process, nothing else. Okay. So just think about it. This is one perspective which I told you, nothing else. Sorry, somebody was asking something.
Yes, sir. We have some questions in chat box.
Okay.
Hi, sir. What will be the future ideas development in this field, sir? I'll
Okay.
repeat once again, sir. What will be the future ideas or development in this field?
Okay. In this field, I guess you are talking about the data architecture, correct? See,
Yes.
the future for okay. Let me give one small example. Okay, data. See, data gets generated everywhere in the world today. Previously, data was getting generated only in the computers, right? You go to a bank, you go to a ticketing railway station to book a ticket, you go to a bus station basically to book a bus ticket, right? Data was getting generated only in those computer terminals. But today, it is not the case. Data is getting generated everywhere, right? You go in the road, okay? There are CCTV cameras throughout, right? They all generate data. I mean, they all generated video feeds. You have Facebook, you have Twitter. So, I mean, the political parties today, they to get in touch with people, they hire specialized IT guys to find out what do the people think based on the social media, right? What is the trending topic in Twitter? What is that people discuss in Facebook, right? So what is that people post in Instagram? Whenever our prime minister does something, immediately there are lakhs and lakhs of memes for and against. Okay, so that's a different issue. But social media generates tons and tons and tons of data. That is one. Then the devices everywhere in the world, even your automobiles, basically a high-end car like BMW, correct? It generates enormous amounts of data today, right? So, for example, if the engine oil is not, the viscosity of the engine oil is up to the mark, the SMS automatically goes to the service station, right? The BMW car, which has been previously serviced 4 months back, is not having the right viscosity in this. Immediately, the owner of the car gets a call. Sir, your car's engine oil is not up to the mark. Can you please bring your car to the service station? Okay. So what I'm trying to say here is, it is not just the people and the computer terminals that are going to generate data. The devices, CCTV cameras, your automobiles, your devices at home. For example, you have IoT-based fans, you have IoT-based refrigerators, you have IoT-based tube lights, you have IoT-based air conditioners. Whenever you park your car, you can send your SMS to the air conditioner and make it a switch on, right? So that is going to be the trend. The devices are going to generate enormous amount of data. So this is going to be the future. We need to have a data design which will accommodate all these data. So this type of data designing is called as polyglot persistence. So one type of data design is called as data vault model. So you can go and research on all these topics. data vault modeling, polyglot persistence. These will be the buzzwords basically in the future. The way in which you design the data. I mean, that is what is going to be the trend. I hope I answered the question.
Yes, sir. Thank you, sir. We have another question. Sir, kindly explain the scope and future of R language with the short points.
Okay, see, R has got a very good future, okay, no doubt about it. But the shelf life for any language is going to be hardly 4 or 5 years. Okay, by if you are in a first or second year of your engineering, computer science and engineering, you have to very much be prepared for one another language also. So that's what I am trying to say. Don't think about R or a Python. Okay, think about statistics. Think about domain. Think about how do I consume statistical tools. Basically in a programming language. Which programming language supports that? Okay, so that is how you have to think. R has got a good future, no doubt about it. R and Python both have very good future, but how long is the question here? Maybe 2 years, 3 years, 4 years, 5 years, we don't know. But don't get emotionally attached to a particular language. But get attached to statistics. Get attached to algorithms. Get attached to machine learning algorithms. Okay, so get attached to deep learning algorithms. Algorithms, not on the language. So that's the point I wanted to make. Any other questions?
Yes, sir. Yes, sir. We have another question. Sir, according to your point of view, how the data analytics differ from data science?
Okay, see, both these words basically are merging together. I mean, data analytics initially took birth, then it became a data science. See, more of data analytics is all about analyzing, building extensive analytics capabilities on what is already there or what has already happened. Maybe the predictive part of it is what is making it as a science. So data science is nothing but a way in which the scientific approach to synthesizing the data. Okay, so both I don't see very many difference between analytics and science, but data science has basically caught on as the buzzword. More or less, both are one and the same.
Next question, sir. What are the skills we need to become a data architect?
Okay, see, as I said, SQL skills, that is the first and foremost. Okay, then the data engineering skills. The case tools can be Informatica, SSIS, like this, or it can be on the big data side, it will be Scala, Spark. I mean, that is what is trending today. Okay, so that is required for data engineering part. Then the data modeling skills. Okay, how do you design relational data models? How do you design big data models? How do you design key value pairs? How do you design document data models? So data modeling skills. Then statistical knowledge. So what are the various statistical tools and utilities that are available? So that is another aspect of it. Then last but not the least, the domain knowledge. So all these things bring together form the data science part.
Yes, sir. We have 2 more questions. What are the challenges in complex data environments and architecture?
It's a very generic question. What are all the challenges in complex data? Yeah, see, in today's environment, as I said, it is not just the human terminals, human beings and the computer terminals that are generating data, right? So the devices, the CCTV cameras, your car, your bike, your air conditioners, your refrigerators, your devices at home, everything generates data, right? So you need to find a way to store all this data. Right? So that becomes the complexity, and you should not have a structured data model and be limited to it and say this is how I would like to store data. Okay, so you need to have open data models, flexible data models, which can accommodate any kind of data. So that is how it is complex. So it is obviously complex to derive meaning out of all these things. So I hope, I mean, these are all the challenges. So, and you know, right, our Flipkart, for example, on day one, 10 years back, when they tried to open the Diwali scale, the server crashed. So they were not able to scale up basically the demand for the Flipkart on the day of Diwali. Okay. So what did they do? They went into cloud and they scaled up basically the data requirement multiple times, and they were able to satisfy the demand. So all these technologies, multiple front of technologies come into picture. That's where the situation becomes very complex.
Thank you, sir. Next question is from a student. What are the certifications that would help us to increase the possibilities of getting placed and to stand out from the crowd?
Okay. See, definitely a Python on R skill is definitely very, very important. And statistical, I mean, there is a mathematical statistical institute available in Chennai. See whether you can get trained on statistics, because data science, deep learning, these are going to be the future. Okay, I mean, the adoption rates have slowly started increasing, right? So you can definitely get science, certified on data science in a particular programming language just to begin with. But the algorithms, getting certified in these algorithms is very, very critical. And you can also, on the infrastructure side, you can also get certified on cloud, like Amazon cloud or an Azure cloud or a Google cloud or an IBM cloud. So cloud also is a very good on the infrastructure side. So all these capabilities are provided by the cloud itself today. I'm sorry. Excuse me. I'll just have some.
Yes, sir.
Yes. Yes, ma'am. So I hope I answered the question.
Yes, sir. Thank you, sir. Just two more questions, sir. Nowadays, applications are done as ready-made ones, such with the .NET, etc. And how the data can cope up with such application, according to you, sir?
See, .NET, I mean, okay, let me try to understand the question. Nowadays, applications are done or ready-made. One such, okay. See, applications are nothing but, I think you are referring to products here. Okay, products for a particular business. Okay, so .NET is one of the methodologies by which the products basically get created. Again, my thing is .NETs cannot scale up basically on enterprise on a huge basis. Okay, so I mean it is not so explosive basically like the Java world. Okay, but you can get certified, you can get but don't stick on to, again, my own this thing. I don't want to stick on to a particular technology, so don't get tied, emotionally attached basically to a particular technology. That is my point.
Thank you, sir. The last question: is there a difference between data architect and data scientist?
Yeah, see, data architect is the precursor of a data scientist. Okay, data architect just thinks about how do I store and organize data? How do I entitle people to use that data? Who should we give access? So who can access this data? So he manages data models, he manages data governance, basically who has to update what, who has to modify what. So data architect thinks about how to organize the data. Okay, a data scientist is on the consumption side. How do I use the data which the data architect has created for this? So how do I monetize the data? So that is what a data scientist thinks in a scientific way. So that's the difference between a data scientist and a data architect. Data architects thinks about how to store the data, how to organize the data, how to govern the data, how to manage the data. Data scientist thinks about how do I use the data in a scientific way to derive value. I hope it answers.
Thank you so much, sir. Yes, sir, it was very clear. Thank you so much, sir. It was really a wonderful and informative session. Beginning from the 2K issue, your discussion about your own life experience, the databases, the evolution of data storage, and the various categories of data model, and the career progression from data analyst to chief data officer, everything was really informative. Surely your words would have shown the thoughts to choose data architect as career option in most of the students' minds, I feel. Thank you so much once again, sir. Dear participants, the feedback link for today's session has been posted in the chat box. Requested to fill your valuable feedback. It is required to get the e-certificate. So now I would like to invite Ms. K. Varalakshmi, Head of the Department of Computer Science and Engineering, to deliver the formal vote of thanks.
Excuse me. Thank you very much, sir. It was a wonderful session for our students. It will be useful for everyone. Thank you so much, sir. Thank you.
Thank you, sir. It is a great honor to propose the vote of thanks at this occasion. On behalf of PERI Institute of Technology, Department of Computer Science and Engineering, I extend a really hearty vote of thanks to our chief guest, Mr. Varadarajan, sir, senior architect, who spared time from his busiest schedule to grace the occasion. Today we had an opportunity to hear your thoughts, sir. It was very nice presentation about the evaluation.
Hello, ma'am. I lost your audio.
Sir.
Ma'am, please unmute yourself.
Okay, ma'am. It is a great honor to propose the vote of thanks at this occasion. On behalf of PERI Institute of Technology, Department of Computer Science and Engineering, I extend a really hearty vote of thanks to our chief guest, Mr. Varadarajan, sir, who spared time from his busiest schedule to grace the occasion. Today we had an opportunity to hear your thoughts, sir. It was a very nice presentation about the evaluation of the data model, and your explanation for the synthesis structured and unstructured data very clear, sir. Of course, data has not changed, but the way we calling is data is changeable. And it was a very brief explanation and how it helps for getting the job. It was very informative session, sir. I am sure the participants gain some knowledge by this session. I would like to extend my profound gratitude to our Honorable Chairman, Mr. Saravanan Periyasamy, sir, and COO, Mr. Sasi Veerarajan, sir, for giving us this platform. I extend my gratitude to our respected principal, Dr. R. Palson Kennedy, sir, for his motivation and guidance. We thank you for being with us, sir. I would like to thank our respected Vice Principal, Mr. B. Magesh, sir, for his moral support and guidance for organizing this event. I would like to thank the faculty members and student participants from esteemed institutions for their active participation in the 3-day technical webinar. I express my thanks to CSE department faculty members for their support. I thank each and every one of you once again for making this webinar a knowledge sharing platform. Thank you, sir. Thanks for sparing your valuable time with us, sir. Thank you once again, sir.
Thank you, ma'am.
Thank you, sir.
Thank you, ma'am. With that, we come to an end of the 3-day technical webinar. So thank you, participants, and we thank the speakers for just giving us the knowledge on various different angles and emerging trends of computer science and engineering. I thank you so much once again, sir. I request the participants to fill the feedback link. It will be active for the next 30 minutes. It is mandatory to fill the feedback form to get the e-certificate. Thank you, everyone. Have a nice day.
you.